Okay, is this showing my slides? Okay, excellent. And I do have the chat. I have another monitor. I have the chat open there. I may not notice if you ask me a question in chat, so feel free to just, jump in if you have a question or a comment or anything like that. So I guess first of all, hi, I'm Mark Newman. I'm a professor at the University of Michigan. I'm actually sitting quite probably just a few doors down from Billy right now, if she's in the office, in D3C, which is where I spend some of my time. My primary appointment is in the School of Information. My background is computer science. And I've been working in this space for the last several years. One of the questioners just talked about context-aware computing. That's kind of where I came into this from. So building systems and figuring out how to design systems that take advantage of information about people's contextual state, their location, their activities, the weather, and these kinds of things, and adapt the behavior of the application based on that information. And as you can see, that there's a very nice connection between that and this concept of just-in-time adaptive interventions. And I've been having a great time learning this space and figuring out how I can contribute to it. And as part of that, I've been involved in a bunch of projects with Billy, with Vivek, with others around building these types of interventions. And I'm going to try to share with you some of what I've learned and kind of walk through the decisions and questions that need to be answered and what some of the options are that are out there. And I'm actually going to do this in the form of sort of 3 case studies illustrating different approaches to building this kind of thing. And we can talk about the advantages and disadvantages of each of these very high-level approaches. So, as I just kind of alluded to, when you get to the point you've thought about the study that you want to run, the science that you want to do, and now you're like, okay, but how am I going to actually do it? I need to build the actual digital intervention and figure out how to get it into the hands of my study participants. Then you have to answer, a lot of questions, about the sort of nuts and bolts of how you're going to do that. From, what platforms are we going to support? Are we going to support, just one of the major mobile platforms? If mobile is the target, are there other devices, activity trackers, blood pressure monitors, smart pill bottles, all of these kinds of things that we're going to be integrating? Are we going, what of the multiple options for connecting with people, sending nudges, sending intervention content, which ones are we going to use? What's the data going to look like? What data do we need for the analyses we're going to do? Where are we going to put it? Are we going to be integrating with other pieces of technology, all of this kind of stuff? And I'm just going to start with sort of painting a picture of sort of the 3 top level decisions. And as you'll see as we go through this, these end up not really being independent of each other. A lot of studies end up sort of borrowing from different approaches. But we can look at sort of the top level. Is there software, commercial software on the App Store that already does what you need to do? And then how can building a study based on that? You can choose one of the many being kind of in the sort of 10-ish sort of credible options for research platforms. Many of you will probably have familiarity with one or more of these platforms that allow you to, sort of go in and configure a study, launch a study, using perhaps, the app that is provided by that research platform. This here is showing My Data Helps, which is a platform offered by Care Evolution, which is a company here in Ann Arbor that I've worked with a lot on a lot of different projects. Most of my experience comes from working with them, but I have looked at a bunch of the competitors and have a decent understanding of kind of how they are similar and different. And then the third option is to build it yourself, basically from scratch, which is writing an app, either by hiring software developers, collaborating with other investigators that have that capability, or contracting with an external firm to build a bespoke application for your study. And so I'm going to kind of go through this by giving an example of projects that I've worked on to various extents, and how those studies were put together, sort of what the rationale was for the choices that were made, and some of the trade-offs. I encourage questions along the way, clarifications, anecdotes, war stories as we go, so you don't have to hold everything to the end. I'm happy to keep this interactive. And so we're going to start with commercial software. Basically, if there's something already out there that allows you to answer your research questions, you should think pretty hard about using it, because that's going to save you a lot of headaches. It might introduce other headaches. But here are some examples. So if you're interested in physical activity, the Fitbit app or other apps, Garmin, Nike Fit, and things like that, have a lot of intervention components that might be of interest to you, goal setting, feedback, and so on and so forth. There might be medical devices like Omron is a company that makes blood pressure cuffs, Bluetooth blood pressure cuffs. It comes with an app that has its own functionality, and various others, Insight Timer, Headspace for mindfulness. I'll talk more about this one, EarKick, which is an AI-based mental health coach. So as I said, if you can answer your research questions without building anything, that's great. You probably can't, I'll just say that right off the bat, but commercial software, even if it doesn't allow you to do everything that you need to do for your study, still might play a role, and we'll look at some examples of how that might happen. But when you might be able to do this is you might be able to add scaffolding around a commercial app to modify or have some impact on the participant experience that allows you to sort of follow through on the scientific questions that you have. And then, as I noted, a lot of times you'll end up using some pieces of commercial software and commercial hardware as part of a more complex intervention using some of the other approaches that we'll be talking about in this talk. So as an example, this is not really per se a JITAI study, although it has some elements that you can think of how they relate to this concept of JITAI. So this is a study that I recently, we're actually writing up the results for this study right now. This is a collaboration with Peja Klasnia and Noel Carlozzi, and then our student Mokchi Bey, who actually did the work here. And the question that we were asking, and this is kind of formative to some work that we want to do down the line, we're actually putting together a grant proposal based on the information that we got from this study. We wanted to ask the question, can an AI-based agent improve quality of life for informal caregivers of individuals with dementia? And within that, which features of such an agent are most important and for whom? And then thinking ahead to work that we would like to do in the future, how does that inform how we might design these types of experiences in the future? So what we did is we gave people this app that was available on the App Store, and gave them instructions on installing it, and had a whole onboarding session. We had to enable some premium features so that they could get access to all of the features. We actually worked with the company to provide us with that capability. And then we also added some additional scaffolding around the app. So in addition to giving them the app and kind of teaching them how to use it, we sent them SMS reminders 2 to 3 times a week. Is basically every second or third day. There was a whole structure around how we decided to do that, and that gives them reminders and recommendations for how to use different EarKick features. And we used a service called Twilio, which is an SMS, basically a software platform that lets you send bulk SMS messages. And then we used Qualtrics for collecting pre, mid, and post measurements. So we quality of life measurements and things adjacent to that. So, the point here is that the primary intervention, as it were, was delivered by this third-party application that we just used wholesale. We didn't modify it or anything like that, but we did provide some kind of scaffolding around suggestions and recommendations and things like that. So some of the challenges with this is that, we noted that the free tier, you would run out of, essentially chat tokens after a fairly short period of time. That was clearly not going to work. We deployed this for 8 weeks to, I guess it ended up being around 30 participants. We collected their data. We had to work with the EarKick company to figure out how we could get access to participants' chat history. And what that ended up entailing is that they had already planned to provide participants or provide users with a way to export their chat history. And so we essentially, wrote into the consent that we were asking people at the end of the study to do, this was on their roadmap, but they hadn't implemented it yet. And so we actually worked with them and were able to convince them to kind of move it up on their roadmap to support our study. They were able to do that, and they did do that. And so we, were able to work with the participants, get consent for doing this. They had control over the export. They could review the export, delete anything that they didn't want to share, and then they explicitly shared with us. We also had quite a long path with navigating our IRB and then our information assurance. So basically the IT, university IT really wanted to understand how the data was being managed and being stored and things like that. But we didn't have to build the software. And given that this was a preliminary study that we didn't have really any funding for, this was the right choice to get kind of started down this path. So some of the advantages that we were able to take advantage of, and that is generally would apply to using commercial off-the-shelf software like this, is it's gonna be polished and usable most of the time. At least you can be sure that whoever is producing it, if they are trying to sell it or use it in some kind of business venture, they are motivated to make it usable, to make it robust, to professionally maintain it, to fix bugs, to update it when there are changes to the operating systems or anything along those lines. And then also it can be cost effective, little to no development effort. And in this case, we were able to make contact with the company, negotiate free premium licenses for the purposes of the study because they were interested in the study. It was an opportunity for them to get kind of a deep look at how people were interacting with the tool and what that experience was like and things like that. Some of the disadvantages or challenges, is as we said, as was exemplified in this, we had little control over the update schedule. Luckily, this critical feature that we needed for our study goals, we were able to work with the company. They're a small company. in startup mode, didn't have, a ton of users that they needed to support. So we were able to, actually get them to pay attention to us and kind of move things around for us. But that's obviously not going to be the case, especially if you're dealing with larger, entities. Fitbit is owned by Google, and they're not going to change their production schedule for things that you need. And it didn't come up in this study, but it's come up in other studies that we've done with commercial software where features can just change midway through the study. They can change the way that things behave. You don't have control over that. It can significantly impact the user experience. I wish I had an example off the top of my head, but I can't think of one. But this has definitely been an issue before. Often, the functionality isn't exactly what you need, so you kind of need to compromise or figure out how to turn things off. So a couple of examples that we've run into in studies are using Garmin devices. Garmin devices by default have a built-in adaptive step goal algorithm, so they actually assign step goals to the user differentially each day, and it's based on recent predicted physical activity levels. And if you're trying to do something that is about that intervention component, about goal setting and goal attainment and things like that, you have to figure out how to turn that off or how to navigate around the fact that the step goal that people are getting, that they see on their watch or in the Garmin app, might be different from what they're seeing in whatever it is that you're trying to provide them. Those of you who have an Apple Watch will be familiar with the breathe reminders, and things like that. So there could just be, features that, are not relevant or perhaps even contradictory to your research goals, and then you have to figure out how to work with them. Also, many cases, the apps, you might have a specific use that you have in mind for your study, and these commercial apps might have a bunch of other stuff that they're trying to provide to what they perceive the users to be that you're not actually interested in. So an example of that might be Fitbits actually do a lot more than just track physical activity. They track sleep. They have capabilities for tracking diet and hydration and mindfulness and all kinds of stuff like that. And these could, at best be distractions from what you want to do, but they could also introduce, confounds and things that change the way that your intervention works. We find in a lot of cases that we need to combine multiple commercial tools to cover various pieces of functionality. I'm thinking in particular of an example of a study where we were using Fitbits and Omron blood pressure cuffs, and we were gave those out to people. This was basically a just-in-time adaptive intervention for people with hypertension to try to motivate more physical activity and more low sodium dietary choices, but also blood pressure self-monitoring. So then you end up in a situation where they have these two devices. They actually had to install the Fitbit app, the Omron app. All those need to be logged into. They need to be synced. They need to be synced with the intervention application that we had provided. And it just increases complexity for the participants, increases complexity for the research team, the coordinators, and so forth. And then sometimes you end up in a situation where you might have feature duplication. So just as an example, Fitbit, which you think of as a physical activity, tracking system, and MyFitnessPal, which we've used for dietary tracking in some interventions in the past. Well, both of those systems have converged to offer all of the functionality of the other one, right? So, but not necessarily very well. So Fitbit dietary tracking is pretty bad. I mean, all dietary tracking is kind of difficult and problematic, but it's really not good. And MyFitnessPal's activity tracking is, it's not their main thing, so it's not that good. And then other challenges that we just talked about in this example, access to data, right? Are things happening inside the app, and is there a way for you to get access to them? And questions that you might ask is, well, even if you can't, maybe get access directly to users' account data, and there's a lot of reasons why you might not even want to do that, can the participants access it and provide it to you as part of your study protocol? Also, is there an API, application programming interface, so basically a way programmatically to access participant data? What does it take for you to access it? How do you get users to provide authorization to allow you to do it, and all those kinds of things. And then a lot of time, there won't be built-in support when you're using a commercial app off the shelf. First of all, nothing really to support experimental designs, MRTs, factorial designs. You have to provide all that yourself, obviously, but also very limited capability for monitoring users' activities as the study goes on. And so you won't necessarily know if people are, even using the application. Are they using it in the way that you expected them to for the study? Are they encountering problems that, that they might not be reporting to you? They lost their login, they can't log in, and they're just deciding to live with it. When you'd really like them to reach out and ask for your help to, get it fixed and that kind of thing. And another problem with commercial software is sometimes it just dies and goes away. So the project that I just talked about, the EarKick study, well, we just learned last week that they are closing up shop and shutting it down and taking it off the App Store because it didn't work out. They weren't able to get to the level where they could be sustainable. Luckily, our initial study with them had concluded, and we got all the data we needed, and now we're doing analysis. But we were planning to use EarKick in a follow-on study this summer, a larger study with caregivers of multiple populations, and we are now having to scramble to either find another application that would provide similar functionality, or move a little bit faster towards building our own capability than we had originally anticipated doing. Another thing that we learned in the last couple of weeks was that the Fitbit API, which we have used in at least half a dozen studies, so we have a lot of experience and a lot of software built for accessing and dealing with data from the Fitbit API. It is being sunsetted. It will no longer operate as of September 2026, which is about a month after we have 2 studies going into the field that are expected to use the Fitbit API. Now, in this case, it's being sunsetted because it's being folded into the Google Health API. So presumably all the functionality that we have been used to and built our studies around in the past will still be available, but just in a different form. But we are going to have to rewrite all that software, and we don't know for sure what's going to be there and what isn't going to be there. So that's something that you can run into when you are counting on other people to provide the functionality that you need. So that's commercial software. So next I'm going to talk about these research platforms that I alluded to earlier. Here are some examples. So Care Evolution that I talked about before. There's a system called Pathverse that originally came out of the University of Victoria that is kind of relatively unique among these types of tools in that it was designed as an intervention platform from the get-go, and I'll talk a little bit more about that later. But I mean, actually, I'll just say, like, a lot of the stuff in this space is primarily, and this might be overgeneralizing because things move fast and are always changing, but many of them were designed primarily as data collection platforms, and they have capabilities for doing EMA and implementing rules for when you might send a request for send a survey to somebody. They have capabilities for push notifications, and so you can use them to build the kinds of interventions that we're often interested in, but it's not necessarily what they were designed for. I included Qualtrics here, which I know many of you are probably familiar with, but Qualtrics actually has quite a bit of capability built into it for doing things like sending, notifications, providing customized, questionnaires for different people, perhaps even based on different information that you might have from other sources. So again, it's definitely not designed as a just-in-time adaptive intervention platform, but it has capabilities that, if you're clever and you are willing to kind of dig pretty deep into it, you can leverage. And we've done some stuff with using Qualtrics to arguably do stuff that Qualtrics wasn't designed to do initially. So some of the common platforms that you would get from these kinds of, the common features that you would get from these kinds of platforms are, things like participant management. So ways to, enroll participants, give them login credentials, securely collect information from them, and so forth. Data collection and storage that you don't have to worry about. It's going onto somebody else's servers. Many of them have, capabilities for building surveys and even some, somewhat rudimentary user interfaces. Ability to send notifications through various channels, push notifications, SMS, email, and so forth. A mobile and/or web client for participants, and in many cases this will be cross-platform. It will already work for the modern versions, the most common devices, most common operating system versions, and so on and so forth. So again, stuff you don't have to worry about. As alluded to, some support for customizing the user experience, configurable, dashboards where you can drop different components in there. At least My Data Helps has some capability for that. Was really only added in the last year and a half, and I know some of the other platforms have some of that as well. And then, there could be some support for defining intervention logic. But often if you're doing any of the kind of stuff that Billy was just talking about, especially if it's leaning more towards the dynamic and personalized end of things, you are very likely to run into some pretty hard limitations of the kinds of rules that you can develop for delivering interventions, in a contingent, context-aware, person-aware way. But they will support things like sending, sending EMA or sending push notifications on fixed schedules. Maybe some ability for making that conditional on other information that the user might have provided, and some of that kind of stuff. And then some of them, My Data Helps being an example, have an API which allows you to write code to sort of operate. So when you run into the limitations of the things that the platform can't do through like the web point and click form-based interface, you can potentially drop out of that and write do your own programming to write the logic that you need, and we have been doing some of that with My Data Helps as well, where we use the platform to do everything that it can do, but when we run into a limitation, we have a server that's running alongside, that's running our code, that's pulling information out of the My Data Helps API, running the logic, making decisions, etc., and then sending information back to My Data Helps to, for example, say, this user needs to get this notification right now, this user needs to get this notification, this user doesn't get one because they were randomized to not get one. Well, actually, we wouldn't necessarily send that to the API, but you get the idea. Here's an example. So this was a project. I wasn't involved with this project until kind of the very end, but it was a precursor to some projects that I worked on. So this was a project called Valentine. The PI, the primary person on this is Jessie Golbus, who I believe is an MHTI alum. I believe she was in the program a few years back. So she's a cardiologist here at the University of Michigan. Brahmaji Nalamatu is a more senior cardiologist who also was involved in this project. And the idea here was this is for cardiac rehab patients or graduating cardiac rehab patients. And the intervention was based on activity goal setting and self-monitoring via Fitbit. So they gave Fitbits to everybody. My Data Helps has a built-in integration for Fitbit, so users can, basically authorize Fitbit to connect to My Data Helps, and then their Fitbit data flows from the Fitbit API into My Data Helps, and then you can, collect the data there and monitor the data and so on and so forth. They used two different types of SMS messages. So these were really the primary, well, in addition to goal setting and self-monitoring, these were two additional intervention components. So activity notifications that would promote activity, and these were tailored by context. So I believe that they were tailored by time of day and the weather. So My Data Helps, actually, they didn't have it before this study, but through Jessie and Brahmaji working with My Data Helps, again, managed to get them to move something up on their product roadmap, which was weather API integration. So the My Data Helps system is able to query the weather report for a user's location based on their zip code, and use that prediction to decide, okay, is it going to be nice and sunny today, or is it going to be cold and miserable, and send different activity notifications based on that information. And then there was another type of notification that was about planned exercise. So this would be in the evening, they would promote planning of exercise for the next day, and this was tailored by the season, but also the types of support around planning changed throughout the study. So based on their cardiac rehab phase, but also their duration, the length of time that they had been in the study. So a couple of dimensions of tailoring on those notifications. And then it was also using an MRT design. So at each decision point, users or participants were randomized as to whether they would, and this was a fixed randomization probability, randomized as to whether they would receive an activity notification or an exercise notification. The exercise notifications were once a day, and the evening activity notifications, I believe, were twice a day, morning and evening, or morning and afternoon. And then this was all built and delivered using My Data Helps by Care Evolution, as noted, but in this case, it did require significant custom development for hire. So the PIs ended up having, essentially contracting with Care Evolution, both to, basically get them to move up some features that they had on their roadmap, but were not necessarily planning to do right away, but also to specifically build one-off code for this project to implement all of the logic for tailoring around these decision points, because it's not built into the platform. This level of tailoring and randomization was not and is still not a feature that is present in the core platform. The API wasn't public at the time, and even if it had been, it wasn't in the budget, or it wasn't part of the plan. I guess it was in the budget to some extent because they ended up paying My Data Helps for it, but they didn't have a development team that could have done the kind of programming that would have been required. So advantages to using going this route is, you similar to the commercial software, you get, a robust delivery platform in that it is the platform's, it's in their interest to make sure that things work. So they will be providing a mobile app to participants that they have tested, that, they're doing their best to maintain and keep up to date with changes in operating systems and devices and so on and so forth. Many of these will have already integrated data feeds from wearable devices or other types of sources. Fitbit, the Omron blood pressure cuffs, and as noted, even something like a weather API. Once they built that in, that's then available. And they do have tools that make a lot of things easy, and the more sort of standard or common the things are that you are doing, the more likely it is that the platform will support doing it the way that you had in mind. So they will have support for sort of standard, types of surveys, and they may even already have some instruments that you can, common instruments that you can choose from. And then within the surveys, they'll have more or less of the kinds of things you've come to expect from, platforms like Qualtrics and so forth, randomization of question order, option order, skip logic, and so on and so forth. They will have, scheduling and sending of notifications, typically on a fixed or recurring basis. Some standard user-facing data displays. So, things like, you might get bar charts showing, step count over the last 7 days as just a standard component that you can plop into the UI, the dashboard that your participants get. Progress bars showing, progress towards a goal today or something along those lines. And then some facility for participant monitoring, being able to see, the survey responses that people have submitted and go back and look through those, the data, like, My Data Helps, you can see the Fitbit data that's been received, notifications that have been sent. You can detect some error cases through this. If you go in and look and you see, that push notification was not delivered and what the error message was and things like that. So they do have some capabilities for that, and that's obviously very useful. And then some of these will offer consulting and development to customize beyond what the tool offers. So as in the Valentine example that we just went through, in addition, Care Evolution at least, and I know that many of their competitors do a similar thing where there's a sort of self-service option where you can just make an account and you can go in and you can configure it and get it ready to go. And then if you run into a feature that you can't do with the platform, they may offer, consulting development services to build the thing that you want or to customize it in a way that goes beyond what you could do through the self-service tools. Of course, that's not free. For some of these, this is actually, in fact, the primary business model, where the bespoke sort of consulting services are how they really make money, and the self-service option is more of like a way to get you on the hook and interested in more sophisticated features. But if they have what you need, this could be great and affordable option. We just went through all of the all of the advantages. You don't have to build your own app or run your own servers or any of that kind of stuff. But disadvantages, as I've mentioned in a few different ways, basically, well, they do what they do and they don't do what they don't. So if you need a particular sensor or third-party integration or particular feature or particular kind of logic, or you want to, figure out how to take a complex study design and, align it to the features that they offer, that's not going to be something that they're necessarily going to have. So the farther you get away from just kind of standard, whatever their kind of standard use case is, the more you're going to probably run into friction in trying to get these systems to do what you want. And then there's, it's also the case that it's hard to predict all of the nuances that might trip you up until after you've committed. So, you kind of have to make the decision a lot of times, at the point of writing the grant about how you're going to build this, right? And that's going to inform the budget, it's going to inform the timeline, it's going to inform the study design and the capabilities and things like that. And so, you'll do a little bit of investigation, you'll convince yourself that, okay, yeah, this looks like it should do what I want. And then there are things that you learn later that were the questions you didn't think to ask. And, these could be things like, the sensor latency. So how long does it take for a sensor signal that was detected, let's say on somebody's wrist, to get from the activity tracker to the app on their phone to the Fitbit servers, or to whatever the cloud server is, through the API to the research platform. And the answer to that question can inform what intervention components and how what and how you would implement certain intervention components. So if once you kind of realize that oh, this is not going to be like immediate, it's not going to know like how many steps this person got in the last 5 minutes, it might not, or the last half hour, or a very kind of rough estimate of how many steps they might have gotten in the previous hour or something like that, that can have a big impact on the kinds of interventions that you might decide to cook up. And then some of these missing configuration options, like you've defined your tailoring variables, you have an idea of what your decision rules are, and you're like, okay, well, clearly they support decision logic, but then that one thing that you needed isn't there, right? That one logic option, that one ability to collect a particular tailoring variable is not there. So that's always, there's always going to be some of that, but it can be it can be rather unfortunate to discover, especially after you've already invested in doing things in a particular way. Actually, an example about this, so the study that was a follow-on to the Valentine study, actually this is the study that's being shown on the screen right now. This was a project called the app was called My BP My Life. This is version 2 of it, but the version 1 is the same. Supporting hypertensive patients. I mentioned this earlier in the context of the app that used Fitbit and OmRun. This study, the intervention was conceived as kind of a mashup of Valentine and this other study that another investigator, Mike Dorsch, here at Michigan had done, that was called Low Salt for Life. And the way that this intervention works is it uses location tracking on the user's phone to detect when a user is about to go into a predefined or is close to a predefined list of locations which represent restaurants and grocery stores that they frequently attend, and it gives them a nudge to help them remember, low sodium choices that they could take in those locations. Well, we wrote the grant. We, decided to contract with Care Evolution, and we went through all of this, and we got to the point where we were actually, we designed the combined intervention that, handled both the activity tracking stuff on the Valentine side and Low Salt for Life. Anyway, somehow we never thought to ask until pretty far in, and when we'd already made choices that we couldn't really back out of, about Care Evolution's support for location tracking. And they don't do it. And it's very clear in their business model that they won't ever add that. They have decided that that's too big of of an exposure for them. They don't want location data. They don't want to have everybody for every study that they support enable location sharing for the My Data Helps app, right? Because it's one app that supports multiple studies, so they can't just enable location sharing for our study. They'd have to enable it for all of the studies that they support, and it was a hard no. They're like, nope, never going to happen. So we had to go all the way back and basically completely redesign the low salt. I mean, it's not the low salt for life study anymore. Like, we just had to basically rip it out and come up with a different way to deal with the notifications, with the intervention around dietary choices. With these research platforms, you have limited control over user experience. So I talked about, basically, like, what you're seeing here actually is a UI that we built completely, and we're running our own web server and hosting it within their platform. So they do have that capability, which is great. But this is not, I mean, not that this is like a wonderful UI, but I mean, it's not necessarily representative of the kind of things that you can do just out of the box. But another issue that we ran into actually with this same study, was, or not, I mean, just, again, hadn't really thought it through until, we got farther into it. The implications of using the actual app that is provided by the vendor. In this case, the app is called My Data Helps. And we were putting together a study that is about helping people manage their hypertension by making, getting more physical activity and making better dietary choices. And the message that we wanted to send to the users or the participants of the study is not that your data helps. It's that we want to provide you with an intervention that will help you with the kinds of changes that you need to make in your life. And that's just not what the app is called. Like, we can't change that, right? And so it's an aspect of the user experience, the framing of the study, the relationship that we have with the participants that we just can't have any control over. And it wasn't, it's okay, but it just became a thing that we had to navigate, right? And then, as I noted before, most of these platforms, were natively designed for data collection, not so much intervention. So you can use the features that they have to do intervention-y stuff, but it isn't necessarily like the primary use case that they're designing for. And so a lot of the friction that we've run into in using these platforms has come around the fact that they're not really optimized for what we're trying to do. I see a question. Do any that allow two-way SMS with the research team? Is that a question about like these research platforms?
Yeah, I had a question. That was my question. These about the research platforms. This has been the one thing that I have not been able to find.
Yeah, and me neither. No, I off the top of my head, no. And yeah, we have thought about that and looked into it before. You can do, I mean, this is a research platform. You could do a version of that with Twilio, but even there, the tools are a little bit, clunky to use. But no, I haven't seen that in one of these. Yeah. Does anybody else?
I've been trying to cut down on the number of apps and tools that the research team need, but that study research assistants need to use, not jumping from one to the other. So thanks.
Yeah, exactly. Yeah. Okay, and so that brings us to our final category, which is the build it yourself category. And so, obviously, this is typically going to be the most expensive and most difficult, but it does give you the most control over all of the aspects, user experience, the delivery and location and naming and of the app itself, the data, the integrations, and so on and so forth. But of course, building software from scratch requires a range of skills that might be not that easy to acquire and maintain. So from UI design to the actual development of the user interface, the backend development, database management, system administration, all of these kinds of things. And then even within the category of custom software that you build yourself, you've got decisions to make about, are you going to build this in-house, meaning like you are going to hire developers that work for you on the project, or identify an entity within your organization. Does your university or your institute have a software development concern that you can work with? That might end up looking more like this other category, which is working with an external agency, where you contract with a development firm or other entity that builds your software to the specifications that you give them. So I'll go through just a quick case study. This may have come up in Billy's talk already. I got there a little bit late, so I didn't see the whole thing. But this was a project that I worked on with Billy and a number of others, where it was a project personalizing JITAI, so that category that Billy talked about at the end. Susan Murphy was also a collaborator on this project. Lara Coughlin is the PI behind this whole thing. But a personalizing JITAI to help young adults reduce cannabis use. So some of the key features: two times a day EMA via push notification, followed by randomized intervention message, and the randomization both decided whether or not to send an intervention message after the EMA, but also randomized across different sort of categories of intervention message. The team was interested in looking at short messages versus long messages, messages that contained external links, messages that contained images, and some other kind of characteristics like that. The personal, okay, yeah. So that was how that piece worked. Was designed as an MRT with a proximal outcome of self-reported cannabis use in 12 hours after the message. So essentially, every EMA would ask about cannabis use in the previous 12-hour period, and then the response to that would be used as the proximal outcome for the previous decision point. There was a reinforcement learning algorithm that determines whether or not to send the post-EMA message. So it starts out, with sort of a fixed probability, but then depending on users' responsiveness and their engagement with the app and those kinds of things, it learns basically a model that determines whether or not to send messages on an individualized basis. And this app has so far undergone a pilot study with 120 young adults for 30 days, and there are plans in the works for a larger follow-up study. And the way that this team was put together is there were a whole bunch of us, behavioral scientists, methodological experts, RL expert, including a PhD student and his advisor, that's Susan. And essentially a full-time research software engineer that during the period of the application development was primarily working on developing MyWaves. We also had some support from students, hourly sort of research assistants that helped with some aspects of the development. One or more statisticians, I think there were actually a couple coordinators, and then kind of me coordinating mostly the technology aspect. So trying to translate between behavioral scientists and the RL folks and the software engineers, and trying to make sure everything was moving along. kind of standard project meeting structure, weekly meetings that depending on, what phase we were looking at, covered aspects of the study design, the science itself, kind of moving into the application design and development, tracking development progress. We, were beta testing within the team as we went along, or as it's sometimes called in software development, dog food testing, from eating your own dog food. So we basically, had everybody on the team install the app, use it as we went along, report bugs, brainstorm ways to make it make the user experience better and things like that, and then moving into analysis towards the end. This whole thing took about 2 years from initiation to study completion. I mean, we're actually still publishing papers from this, even though I think the last participant, it's definitely been more than a year since the last participant finished. Multiple rounds of beta testing, and then we had rolling enrollment across 3 months. So this is a pretty large scale, relatively heavyweight process. Just to give you kind of a, what the point of this being, wait, where did it go? Okay, oh, I see. The scroll wheel goes the opposite way than I thought it would. To kind of give a flavor of what a custom software build, might look like. And I would argue this is not necessarily uncommon. This will not be tremendously interesting perhaps to many of you, but here's kind of like the architecture just to give a sense of what the different pieces are that need to be considered when building what's often called a full stack application. Full stack meaning that it's both the backend, so the database, the server that manages the database, and the client, in this case the MyWaves app, that was built using React Native and distributed via the iOS and Android app stores to the participants. There's also a dashboard that was built for the study team to monitor participant interaction, any system failures or oddities, and so on and so forth. And then there was sort of parallel project that the application proper was interfacing with, which was the reinforcement learning server that was actually built and hosted on a separate server. And then there was a communication layer between the MyWaves server, the decision rules on the MyWaves, within the MyWaves application, and the reinforcement learning algorithm that would basically tell the decision rule whether this user should receive an intervention or not. So advantages, we sort of talked about this a little bit already, but almost complete control over the UX, data collection, and so forth. Again, with limitations, even in this case, we're interacting with some, actually in this case, there was no Fitbit, so it was a little bit less of a case of having to interact with third-party systems. So we did have actually quite a bit of control, other than the limitations of the mobile phone operating systems, the database architecture, all those kinds of things. So you do run into some of those. And obviously, this approach allows you to innovate beyond what platforms and commercial software offer. So, one thing to think about is that these platforms, things like, My Data Helps and Pathverse that we talked about before, are always going to inherently lag behind what's possible because they're providing, sort of a wrapper around, the things that are offered by the operating system, by third-party sensors and integrations. If you do it yourself, you can basically get access to those things on your timeline, not on their timeline. They're always going to be looking to support the majority of potential customers. So if you're sort of out on the fringes of the types of things that their customers are doing, you're probably not going to get the capabilities that you need. The big disadvantage here is that they're generally more expensive, but I would say, especially when you think about building yourself with your own, like hiring a development team and having your own development team, it's not just a question of, how much time is it going to, and how much is it going to cost to build this one app, but how are you going to maintain that team, keep them motivated, make sure that they have access to career advancement capabilities and stuff like that. So there's just a lot of stuff around, maintaining a software development team that, is beyond just hiring people to do the work that you need to do. This often pushes people more towards working with external, whether external means elsewhere in your organization or outside your organization through contracting, so that those additional layers of, sort of having a team and keeping them fed is less of an issue. Also, you don't really get out of being reliant on commercial software and platforms. So a lot of the limitations that we talked about, well, at least some of them can continue even if you are building. You're going to, end up needing to use other services in many cases to just, Twilio is a popular option for sending SMS, Fitbit for collecting sensor data, et cetera, et cetera. And then, okay, I guess I just talked about this, but yeah, some of the additional challenges of, in-house development, it's not just the actual development, which is challenging enough in itself, but, the personnel, right? It's a little bit easier to hire programmers right now than it has been in the past. But, it is not always that easy. And then externally, when you're working with external, contractors and, people that are not part of your team, you've got challenges around communicating requirements, very easy for misunderstandings to, to come in. We tend to use both, software developers and behavioral scientists and health researchers have very specialized lexicons and words that you think are very clear and mean this one very specific thing might mean something very specific, very different to somebody else's ears. And again, these are, things you might not realize were misunderstood until significant effort has been invested. Just the whole negotiating contracts, being able to accurately scope the work, figuring out, is the vendor going to provide maintenance and for how long? Are they going to support the study during the entire, during the entire run, or are you just going to be kind of left holding the bag? All those kinds of things. And actually, let me just pause here for a moment before I get into the concluding part of my talk, which is a shameless plug for the project that I'm working on. So we have a chat. What are the key decision points, key influential factors in terms of choosing commercial software versus research platforms versus customized ones? I mean, that's a great question. And I actually started out when I've given this talk in a couple different versions now, and I started out trying to map that out, and it's very difficult. It's very specific to the project, but I would say what was I going to say? I was going to say something, and now I can't remember what it was. I mean, unfortunately, most of cost and timelines end up being huge, right, in the kind of work that we do in health research, right? Grant proposals have certain size. There's norms around, what the software budget can be, what the timelines are, and things like that. And in general, that I think is going to push people towards things that at least appear initially to be less expensive and give you a leg up, allow you to get started. And so that would push you towards commercial software and research platforms. And so, I think a lot of it is trying to, really think through the, like as much as you can of the details of, what kind of interaction you need to have with the participant, what information do they need to receive when, and what data do you need to get from them, and think through like how is that going to like kind of work in terms of the pixels on the screen and the buttons that need to be pressed and when they need to be pressed, so that you can really realistically evaluate, whether an existing offering, whether that be commercial software or a research platform, is really going to end up giving you what you need. And it's very hard to do, in advance, but that's kind of the thing that you kind of, need to think through. It's not a very satisfying answer, but I would say that's kind of the issue. All right, I'll go forward, and if there's any more questions or follow-ups, I'll pause. This is so I'm going to talk about a project that I'm working on that's still very much in progress, but something to keep your eye on maybe coming your way. We're looking at our first major release later this year, probably towards the end of the year. I'll just take you through this. So this is a slide that shows JITAIs that have been built just at the University of Michigan in the last like 5 to 7 years. And this is not even complete. There's stuff here I couldn't find the logo for, stuff that's being built right now. And the thing to note about this is, first of all, like that's a bunch of them, right? And this is at one, admittedly large, but one university. And it, for the most part, every one of these was built from scratch. I mean, some of them were built on top of research platforms, but the ones here that were built like with CareEv and things like that, it included heavy customization to the extent that it almost looked more like a custom build. And these were built from scratch. So we're just essentially reinventing the wheel over and over again. And why does that happen? One reason is that these were different research groups, that interact with each other to different extents. They have different teams, different people are building them. There's not, a lot support and resources and facilities for we're trying, people are trying to find better ways of doing this, but they're not necessarily easy to do. But even within that, a lot of the apps that, are built for these projects are not written in a way that would really support reuse. Because writing reusable code takes more time and more effort and more forethought than writing something that is kind of like duct taped together and just is good enough and put together enough to get you through the study to collect the data that you need, and then you get the renewal, or somebody else wants to do something based on your thing, they go in and try to reuse it and find that it is just not really possible. This is caused by deadline pressures. A lot of times, the developers, whether you're hiring them or even contracting outside, this will be the first time they built anything like this, right? And they learn a lot of stuff that they would do differently if they had a chance to do it again. But a lot of times, by that time that comes around to do it again, they moved on to something else. or it's just not really, the system is not designed to support this kind of thing. If you work with student developers, as somebody who teaches student developers, I can tell you that their software engineering practices leave something to be desired. When you work with external developers, the code may not be easily shared. There can be complications around licensing and ownership and intellectual property and who actually owns the code and who can do what with it. You can work those out, but you need to know what questions to ask. You need to know how to write those agreements to make sure that you can get what you need. And again, even though these might be professional developers, they may not have worked with just-in-time adaptive interventions before. In fact, in many cases, they haven't. And so they're not necessarily, writing it in a way that would support reuse of that kind of thing. Another issue that we've run into with building, especially building custom software to integrate with research platforms, like Care Evolution, or even worse, when the research platform, the vendor themselves does the customization, is that code or the functionality that was created is not easily, well, so if we build it, we can decide to share it, but if if it's built by the engineers at Care Evolution, like in the case of Valentine or in one of these other platforms, they're going to own the code. It's not necessarily going to benefit other people. So there's no ecosystem around, these kinds of things. And so, of course, this is all bad because it wastes time, effort, and money. PIs often end up disappointed because they don't really get what they wanted. And then the field as a whole doesn't benefit from the work, often considerable work that's done for each individual project, because we can't take that work and then apply it in a new project. So the vision with the Justin project, Justin is for just-in-time adaptive intervention, is we're creating an open source platform and community, and the community part is critical here, of researchers and developers that we envision will enable, encourage, and support contributions from the community to enhance and grow the platform. So an example of this would be your, maybe there's, you decide that your project, you want to use the Aura ring, or you want to use some exotic sensor that's being developed by people at your university, like the stress sensor that Billy talked about. That was a custom bespoke sensor that was built by folks at the University of Memphis. And you do all the work to build that and to make it work with your intervention. We would like, it to be the case that if you build it to work with Justin, that it could then be available to anybody else who also builds interventions that are built to work with Justin. So we are building this platform to build, curate, and share technology, so reusable components like I was just describing, but also a common sort of place to share knowledge and best practices around how did you put this your intervention together to support this methodological approach. What best practices did you learn about, like the gotchas with interfacing with the Garmin API or something like that. And we want other researchers to not necessarily fall into those pitfalls. And we want to do all of this by providing a low floor and a high ceiling, meaning that the barrier to entry to building your first JITAI with Justin, we want it to be easy to do those common things that you need to do, but also the ability to customize and do things in a flexible way as needed. So I'll just kind of quickly talk through how are we going to do that? How can you make something both powerful and easy to use? Well, we have a layered approach where there will be a larger set of functionality that you can access through actually programming, software development, things that you can do through kind of more, sort of system sysop level configuration, and then things that eventually you could do through a point and click graphical user interface, such as is supported by the types of research platforms we were looking at before. You can sort of look at these different layers as being aimed at different audiences. So behavioral scientists who don't fancy themselves as programmers or system administrators would be primarily working with the GUI. Some of these more technical research admins who are not quite software developers, but the kind of people that could make Qualtrics and Redcap do crazy things that you never imagine, would be interacting with like the configuration layer. And then of course there would be, functionality that could be provided. It still requires software development, but potentially at a much lower cost and effort than the current state of the art. So these are kind of phases, over time. We're right now building the programming layer, and in fact, we're right about here. So we got a ways to go, but we have been building this, and again, we're looking at a Justin 1.0 release later this year, and our goal for Justin 1.0 is that you, dear behavioral scientist, should be able to hire an undergrad CS major, junior or senior, and build a JITAI of moderate complexity, let's say, with 2 to 3 intervention components in 3 months. And that should set you back about $10,000. You can compare that to something like iWaves or something, the current state of the art, which is probably going to look more like 18 months and about 150K. This is what it looks like, and the thing to get out of this is that all of these kind of purpley blocks are custom code that need to be written, but only the things that are special to your intervention. All that common boring stuff like user authentication, secured data, storage and transmission, basic monitoring views, support for authoring decision rules, and so on and so forth, that is handled by the platform. And so here's the current status as we sort of wrap up, but we have a study in the field right now, another study being finalized. The study in the field right now only uses part of the Justin platform, which is the decision rule engine, and we're actually using this with the My Data Helps platform. We have 2 full stack apps in development that will launch this summer. And our team right now looks like 2 full-time developers. I'm not one of those. I'm me, I guess. I'm the third person. And then 5 independent study students who are working, and we kind of have a rolling intern program that we're working on. We have some funding for Justin itself. So supported by a P50 that Billy is the lead on. We got an RO3 from NIH NIDA that was through a program supported by the Office for Data Science and Software. Very exciting program to support this kind of work that is really the infrastructure to support the science. And then we have some from NCATS, and we have several other in process. But then we are also, have several specific intervention RO1 type projects with NHLBI, National Institute for Aging. This one is under review. NIH is under review as well, and several more in the preparation stage. So as I said, watch this space. Looking for a release of the initial platform with documentation and tutorials and example apps by the end of this year. So if you're interested in finding out about that, we have a mailing list. I actually don't know how you sign up for it right now, but I could get that information for you if you're interested. And to wrap up, there are many options for building your JITAI. We talked about commercial software, research platforms, custom build, and some of the trade-offs. There are unfortunately no real easy answers, but at least hopefully being aware of the landscape and some of the questions that you should ask will help you prevent disappointments in the future. And many projects end up kind of taking a hybrid approach and borrowing from each of these approaches. And then I talked about the Justin framework and why we're doing it and how we're doing it. And that's it.
Terrific, Mark. That was quite a bit. And we will take one question. Dorina, actually, Michaud has asked, what are the key decision points? I think it's in the chat.
Yeah, I mean, I did address that verbally to the best that I could. It's one of the unfortunate things about this sort of grant-driven research is you often need to make decisions, when far in advance of when you actually need the software to be built, and that could result in both the landscape changing, devices that you thought were going to be available are not available. Sometimes better devices become available. Platform capabilities can change. Research platforms can change. Commercial software can be removed, and so on and so forth. So I guess my general recommendation is estimate on the high side, assume that things are going to take longer and more, and you're going to need more resources to do software development. Then, don't be optimistic. Don't plan for the best case scenario, but think about, what could happen if you need to pivot, if things maybe take longer than you expected. Okay, it'd be helpful to learn more about the revenue models for app companies. Yeah, and yeah. Did somebody say something? Okay. Yeah, no, it's and that's a great question to ask, and it varies from place to place. One thing that just happened recently with My Data Helps is they had a free tier where if you had less than 100 participants, you could use their platform for free, and they took that away. And it looks like they're going to have a pretty high starting cost that's somewhere in the neighborhood of like $50K a year to use their services, right? And other places have a again, kind of like a self-service tier that might be very cheap or free, but limited capability. Is something called the freemium model, where to get more capabilities you might have to contract with them to do more and things like that. So it's kind of all over the map. Some of these have like grown out of universities, and they're run more like nonprofits that are just trying to kind of like help the community and be sustainable. Others of them are much more looking to be profitable. And these are really important questions to ask when you're considering making a decision to partner with one of these platforms or commercial apps.